The circles H and K have diameters AB and AC respectively. Prove that EB, E to B has to be parallel to D to C. Alright, now first thing we're going to go through is the following, alright? Does everybody remember this from earlier? Okay. So everybody remembers that this is, for argument's sake, 90 degrees. That's 45. Yeah. Everybody cool with that? Now what I'm going to do is I'm going to move up the legs of it so it's a diameter. Okay? So I'm going to move it up that straight across, and it's essentially a diameter. Now what do I have to do to the legs of the other one? Move it across like so. Okay? And everybody cool with that? Now what angle is it now? And what angle is it on top? What does that always mean? It means that the angle in a semicircle is always 90 degrees. Is that okay with you guys? So, angle AEB. What do you think AEB is? Reason? Angle in a semicircle, okay? Any other ones that are 90 degrees? ADC. Does everybody see ADC is also in a... Yeah? And it also specifies that the diameter is at the start of the question, doesn't it? So ADC... What? Yeah, one step at a time for me, Charlie. Says I'm not a smart man when it comes to these. Okay, so I'm just writing down my reasons, making sure everything's above board. Alright, Charlie, what are you going for next?
EBD is also 90, because straight angle, one's 90, the other has to be 90. EBD.
EBD?
Sorry, BED.
BED. Yeah, BED would also be 90 degrees. Now, I think what we're trying to prove here is that if this red one's the same as that red one, I think we've actually done it.
Yeah.
I think we've proved that both triangles have exactly the same angles as each other. And therefore,
Angle.
yeah, all triangles are the same in both triangles, therefore they're parallel. So what we'll write down next is sorry? So what we next say is that we have to spell it out for them. AEB is equal to ADC, and then you say therefore what we're saying, EBA is equal to what? DCA, is that correct?
Yeah.
Reason being it's the third angle in a triangle.
Can we just label them like angle 1, angle 2?
Yeah. You can just completely put numbers for everything and do it with numbers, no bother, right? Third angle in a triangle. So what does that mean? It means they're corresponding angles. So what did I say? AEB. So what can we say about these two angles then? ABE and... Sorry, let's just do that. Yeah. So, therefore, 3 dots means therefore, what's it? EB is parallel to? EB is parallel to DC. Because they're the same angles, aren't they? Yeah. We all good with that? Alright. Tricky. Lads, you remember what I taught you in the last one? That if that's a diameter, yeah? I'm thinking, if I can prove that this one's 90 degrees, and I can prove that this one's 90 degrees, I can prove that QS must be the diameter, because they're standing on the same arc, aren't they?
Yeah.
No, yes. And therefore, if I can prove that they're 90 degrees, then it'll be the angle in a semicircle, won't it? And that means QS will be the diameter. So that's my goal. My goal is to prove that QPS, the goal is QPS equals QRS, and to prove that both of them equal 90 degrees. We cool with that? Alright, we can do numbers this time. I know you guys were preparing the numbers. So we'll just call them those two angle 1 and angle 2, okay? So we call you so they're currently not 90, so I can't use that. So you're angle 1, you're angle 2, you're angle 3, you're angle 4, you're angle 5, and you're angle 6. We all go with that? Alright. So what we're going to say is that to prove angle 1 equals angle 2 equals 90. What we given? Angle 3 equals angle 4 and angle 5 equals angle 6. We all okay with that? Now, what can you tell me about cyclic quadrilaterals?
Well, opposite angles equal to 180 degrees.
Exactly. Opposite angles equal 180 degrees. So, can I just finish my thought? Thanks. Right. I could be wrong, but I just still want to finish it. Alright? What I'm going to argue is that angle 3 plus angle 4, what am I going to say there equal to? 180. And what's the reason for that? Opposite angles in a cyclic quadrilateral, or I'm going to type that out. Probably spelled it wrong. Is that right? We cool with that, guys? Opposite angles in a cyclic quadrilateral, okay? Happy days. Alright. Okay, now I'm still trying to finish my thoughts here. Okay. So therefore, we have it. So, essentially, we could argue that that's 2 times angle 3 plus, for argument's sake, 2 times angle 5 equals 180. Would that make sense? Replacing, because angle 3 and angle 4 are equal to each other, and angle 5 and angle 6 are equal to each other, I could also say that 2 times angle 4 plus 2 times equals 180. And then what can I say? Divide both sides by 2 then, don't I? And what will I get then? Angle 3 plus angle 5 equals 90. And then what can I say about the other one? Equals. Therefore, angle 1 equals angle 2 equals 90 degrees. Why? Third angle in a triangle. Because all 3 angles in the triangle have to add up to 90. Charlie, did you have a different way of doing it? Or?
Yeah, I don't know if it's similar, I don't know if it still works, but
Probably. Go on. Alright. Just let me finish. Just writing at the end. Third angle in a triangle. And we probably should explain why. So, angle in a semicircle. As they're both standing on the same arc. What arc are they standing on? As they're both standing on the arc QS. The writing is important in this, I'm afraid. I wonder what it says here. It just says angle in a semicircle, so therefore QS is the diameter. Alright guys, I've sadly run out of time, so will you guys try 2, 4, 6 and 8, and we'll have a go with tomorrow, okay? I'll put